All right, guys, so today we're going to finish lesson 2, and we're talking about how atoms bond. So atoms combine chemically to form compounds, and compounds make up the most of the matter around us. So a chemical bond is the force that holds two or more atoms together. And atoms depend on our electron and number arrangement. So remember, in the nucleus, you have protons, which are positive, and neutrons, which are neutral. Outside the nucleus, you have electrons, which are negative. A neutral atom, your protons or your positives, always equals the electrons or the negatives, so the charge of the atom is 0. The electrons are outside the nucleus and move in an area that correspond to its energy level. The energy levels are the areas of space where our electrons move. If they are close to the nucleus, they have the least amount of energy. The furthest from the nucleus is the most energy and our highest energy level. The first energy level holds 2 electrons, and the second energy level holds 8. Electrons are what are important when we are talking about bonding. So the negative electrons are attracted to the positive protons in the nucleus like a magnet. Close to the nucleus is a strong attraction, and further away is a weaker attraction, and they are attracted to the nucleus of other elements. That attraction is called a chemical bond. So our electrons involved in bonding are the outermost electrons, and they're called valence electrons. They have the most energy, and the number of valence electrons will determine the number and types of bonds an atom will form. So we determine the number of valence electrons by looking at the outermost. So there are, for sodium or Na, we put 2 electrons in the first ring. And remember, the second ring only holds 8. So then we put our final electron in the outermost ring. And we're going to come back to this. So just jot this down, and then we're going to do some activities with them. So another way to show electrons is an electron dot diagram. This was developed by an American chemist, Gilbert Lewis, in 1916. And this is a model that represents valence electrons in an atom as dots around the chemical symbol. And it's used to help us predict how the atoms will bond. So if you look at the steps, you're going to write out the chemical symbol, then find the number of valence electrons and draw them around the configuration. So you can copy this down in your notebook, or steps, and we'll come back to this because we're going to do an activity on it. Okay. Group 18 are our noble gases. They have 8 valence electrons, so they are happy. They do not easily react or form bonds. So this is our last row in the periodic table right here. These nonmetals, you can label them on your periodic table as noble gases, and they will not bond because they don't react easily. Okay, so atoms form a bond to lose or gain electrons to become more stable. So an atom will lose, gain, or share electrons with other atoms to become more stable. And they are most stable when they have 8 valence electrons. So basically these atoms want to get to 8, so they're likely to form bonds with other things. Okay, so that's it for today for your notes. Next, you're going to go to this packet, and you are going to, then we are going to work on page 1. So for page 1, you're going to define family and period. Okay, and then tell me what is the symbol for each element. Family is another name for groups, or your columns in the periodic table. Then you're going to look on your periodic table and tell me what are the symbols for magnesium. So for example, magnesium is Mg, and you can find the rest of them. Then you're going to identify the element's name for these symbols. Then tell me what period these ones are found in and what group these ones are found in, okay? And then this one, you can just, don't worry about number 7, cross that one out. So then we're just gonna do 1 through 6 here today, and then we'll go over them and go over our notes when we get there. All right, have a great day.